Hello my dear champions, welcome back to the class. Today I am here to discuss one very important concept from the chapter of integrals, right? Have you seen those questions where you have to use this by parts condition 2 times and we start to struggle in that, which has to take more time in that questions, right? So in this session I'll talk about different forms where you can find by parts, means different type of questions. Alongside that I'll give you the basic rules, the basic funda behind this particular concept, and we'll solve 3 questions on this as well. Okay, so let's discuss this chapter in a small session to get our clarity that we require to solve questions on integration by parts. Okay, so let's start the class. This is the fundamental form by we have the 2 functions u and v. You gonna keep u as it is, integrate the first function which is v minus u dash v, integration again same thing repeats dx. This is the fundamental form. Let's look at it, don't worry, let's look at it in detail. First thing first, why this part is required? What is this by parts meaning? This is basically, if you actually go about it, this is the inverse process of differentiation in product form, right? Inverse process of differentiation in product form. For example, if you had to differentiate u into v, the product rule, what are you gonna do? Differentiate u keeping differentiate v keeping u as it is, and differentiate u keeping v as it is. Okay, something like that. But of course in the case of integration there is one more important addition, and that is called as preference. So there is no preference given when you are doing the differentiation, right? Can you recall that? If you are dealing with the product rule wala questions, you don't have any priority over there. But in the case of integration by parts, you have one very major difference, that is called as preference in the functions. Okay, we'll of course look at the ILATE condition later. And how does it work? So if you are looking for uv, okay, you're gonna get what? Integration of u v dash dx plus v u dash dx. That's the opposite part, right? So this is how you get. Check this out, v dash dx, the first part becomes uv, where this is the first function, minus v u dash dx. This is again the integration. This is same as the first part over here. Check this out, v dash dx integration will be what? What is this going to be? Simply v, same comes over here. So first function is going to be integrated over here. Different forms we use it over here is algebraic and trigonometric, right? When you multiplication of x sin x like that, or x tan x, very commonly occurring questions. Then algebraic and exponential functions. I mean, these are the major types of questions that keeps coming to us in the examination. Inverse of the function means inverse of ITF. Okay, what are you gonna do in this type of question? If you have only tan inverse of x, then what you do? You multiply 1 with it and start solving it from here. Okay. Logarithmic alone, if you have exponential times of trigonometric, so all these types are there. We'll look at that. Okay, so this is very, very important. Which one is going to be u and which is going to be the dv form? U or dv, which is going to be the case. Starting always from what? Starting always from the preference, the priority order. Okay, pick u as the function that appears first in the priority order. So first function is always kept as it is. Second function in the priority order is integrated first. So if you look at the formula over here, first function, if my first function is u, I'll keep it as it is, u, and integrate the second function which is v dash, then again minus, differentiate the first function which is u dash and integrate the second function, take the whole integration again. So if I have to simplify this in the simplest way, let's try. If it is my first function and second function together, what I'm going to do? First as it is, integrate the second, minus, differentiate the first and integrate the second, and their product you have to take and again integrate it one more time. Again integrate it one more time. 1 second guys. So you have a overall integration one more time over here. So first function as it is, second function integration, then differentiate the first function, second function integration, again whatever you did over here, same you write over this point, and then multiply, integrate one more time, right? Great. This is the condition. Now the preference order or the priority order goes like this: I for inverse trigonometric functions, L for logarithmic function, A for algebraic function, which is always in the middle, and T for trigonometric, and E for exponential function. Okay, this is the condition ILATE. Of course, forms are sin inverse, tan inverse, log x, ln x, whatever it is given over here. Based upon the question that is given, you're going to choose the first function. U, if it is my first function, I will take it as per the priority order given in ILATE, ILATE. Clear? I hope this is clear. Great, sir. This is my golden rule, and now we're gonna go to the forms, different forms of by parts that we have. The first form is very simple, the standard form, right? You have u into v, where preference is, let's say this is my first function, this is my second function. You're gonna start with first as it is, integrate second, first derivative, integrate second, product, and their their whole results, integration. Okay, example, we can take x sin x. Okay, x is what? Check the rule, ILATE. So AX is from algebra. So algebra has the preference. X is algebra. Sin x is trigonometric. In ILATE, algebra has preference over trigonometric functions. So you're gonna keep x as basically u and v as sin x. So u will be as it is, you can see. U as it is, integrate sin becomes minus cos, minus differentiate x, that becomes 1, and integrate sin one more time. The same value you can see over here is as well. Again, simplify this by integrating cos again, you're gonna get sine. This will become plus because of the presence of this minus and this minus. You'll have 2 minus sine, it becomes plus sin x. So x cos x minus x cos x sin x plus c. A simple question. Always keep the same choice. So once you started with the preference order, first and second, do not interchange in the expression. Let's say over here I've taken first function something different, here I cannot take different. Okay, if u is my first function, same will be over here in the second branch in all of my steps. Okay, form number 2. This is very commonly occurring MCQs in boards as well as sometimes in the CET as well. So whenever you have this, is as per NCERT only. There are different forms of this type of function. If you want me to give you that, let me know that in the comment section, where you have exponential function multiplied and this type of result is present. There are multiple forms like this. Let me know if you want that. I'll give you that in the upcoming sessions. E power x fx plus f dash of x is there. Then what is the integration of that? Simply going to be e power x fx, right? E power x fx. So even this type of form is there. By parts only condition is there. You continue. This is the final result. You just have to remember this particular condition. That'll be enough. Special case of integration. Okay. Second form is done. Next example is also taken over here. E power x x we can take. All right. All right. Next, single function. The form is single function. When you don't have anything, just let's say you have just fx present over here. Just you have fx over here. You're gonna multiply that with 1 and take derivative of this dv as 1 dx. Okay, basically this is my going to be second function. Fx is my first function, check here. Fx is my first function, so I'm going to keep tan inverse as it is, integrate 1. So I've taken this as tan inverse of x into 1 dx integration. Okay, this is my first function and this is my second function. Check. Tan inverse as it is, integrate 1, that will become x. This time differentiate tan inverse, again this will be x. Okay, you'll have to integrate one more time, x upon 1 plus x square by using substitution method. This is, what is this? This is the substitution method to get the result. Will come as x tan inverse of x minus half of log of 1 plus x square plus c. The third form, first form is the standard form, second form is where a special case of ex times of fx plus f dash of x is there, and third form is when you have only one function, you multiply with 1 to present it as second function in the priority order and start using the same process of uv integration. Okay, the by parts integration. All right, different forms that it applies to usually in the question solving. Log x sin inverse of x, excuse me, 1 second guys. So log x, yeah, just a second, yes, 1 second, just, all right. Okay, here it is. So log x we have sin inverse, cos inverse, tan inverse are the different forms where it is usually asked in that, especially for the board style, they can ask this kind of question. Okay, yes, let's move on then. Form number 4, when you have more than once, basically when you continue solving it, even the second branch acts or becomes another by parts. So you have recurring by parts form, recurring integration by parts form. In that case, what happens is, for example, in this question you check e power ax sin bx dx becomes what? E power ax a sin bx minus b cos bx upon a square plus b square plus c. Okay, if you want to differentiate this side, you're gonna get, yeah, differentiate this part, you're gonna get this result on the left hand side. Getting it? Great. Okay, so recurring means when you get to apply the integration by parts 2 times, guys. 2 times, okay? And what happens in those cases? So basically after 2 rounds of IBP, basically integration by part, the original integration I reappears. This is original integration I reappears, and you have to basically take all the I on the same side. For example, I can have, let's say, I minus something over here minus I. I'll put it on this side. I get 2I equals to this result. Then I will become what? This result by 2, whatever it is, based upon question to question. We have this also in one of the properties of definite integral, if you remember, right? So you don't integrate again, just bring it to the left side and solve like a equation for I. This kind of question is there. Where you reoccur means you have more than one time of integration by part, and after 2 times what happens? You get back the same original function or the integration given to you, okay? Same original integration given to you. All right. If you want, just try this. Try this question. E power ax sin bx dx. Okay, you have exponential function over here and sin bx. Okay, try this out. Okay, then this is definite integral by parts. What happens if you have limits involved? So very simple, sir. Since you are integrating this value v first, you will apply the limits only for this part, and once you have the second part integration done, so limits also again will remain same. So you can either go with this formula or simply do the entire integration using by parts, and finally once you have the result with you, use the limits. Use the limits. Clear? Yeah, use the limits. Sure. So either you can go with the form that you have, whole integration a to b. Again here integration is yet to be done, so once you finish that, you're gonna put that value of lower limit as a and upper limit as b. Usually what happens, what we do is continue with the entire process using indefinite only, and at last we put the value of limits. So these are the different forms that we wanted to explore in by parts. Okay, let's look at some questions. X e power x dx is there. What is this going to be equal to? Which form is this? Check here, x e power dx. So we'll have to write first ILATE condition, right? ILATE condition. Look at this. So we have algebra and exponential. Algebra has the preference, sir. So I'll keep x as it is. Integrate e power x minus differentiate x. You're gonna have 1 e power x integration is e power x only. Continue, please. You'll have x e power x minus again e power x. Take e power x common. You'll have x minus 1 plus c. This is actually a standard form also. Please try to remember this. X e power x or t e power t. This is a standard form. The answer is e power x, x minus 1. E power x, x minus 1. Check. E power x, x minus 1. I have given you a detailed solution also. You can refer it over here. Option A is correct. Yeah. Option A is correct. Clear, guys? Clear, right? No problem over here. Log x dx. How to solve this question? You'll take log x into 1 dx and basically multiplying with the third form where you have only one variable given. Only one function given. So you're gonna keep this as first function. So log x as it is, integrate 1, you're gonna get x minus differentiate log. You'll have 1 by x. This will again be what? X only. Check this and this cancels. I'm getting x log x minus again integration of dx. It becomes x log x minus x plus c. X log x minus x plus c. Option is A. X log x minus 1 minus x plus c. Okay, if you want, you can take x common. It will become what? Log x minus 1 plus c. Check. X log x minus x plus c. Right? Second form is also discussed. Let me know how many of you are finding this session helpful. Okay, so what I thought is let's get into a class, a small session where I discuss one concept. Okay, and because of that, our understanding of that part is clear and we can start solving questions on that. Okay, so that's why I am doing this simplified versions of the concepts solving using problems in these sessions. Let me know how you're feeling about these. Based upon that, we can make it better, make some changes as per your requirement. All right, and I have a very important update for all of you. Just wait for a minute. I'll give you that right now. Okay, just let us finish this third question. What happens, sir, if you have e power x tan x plus 1, secant is also there, secant x is also there, dx. What is the question of this? So whenever you find e power x, fx together, okay, together, always look for the form that you have. What form is that? Check, cross multiply, integration e power x, then if you multiply secant x inside the bracket, you'll have tan x secant x plus secant x. The form is true only when if you have fx and f dash of x together. If this is my fx, then what is this? This is my f dash of x. Derivative of secant of x is what? Tan x and secant of x, right? So this is my fx, this is my f dash of x. If you integrate this, you'll have the answer as e power x secant x plus c. They're asking you to compare this with this fx and write the value of fx. What is my answer then? Clear, sir. Answer is option A. Secant x is the answer. Secant x is the answer. Check. This is the answer. This is about our by parts and the various forms, various questions involved, okay, in the different forms. All right, so let me know how was this session. And again, I have a very important update regarding our Pariksha Veera batch. Because of the Independence Day, we are giving you a very special, offer in the course. Okay, it's going to be only valid till Sunday night, Sunday midnight. You have to enroll before that. So we are providing you all the Pariksha Veera KCET batch of 2027 for a price of 2499. Okay, 2499. This is again at a 50% discount beta. The actual fees is close to 5,000 and this is only at 2499. Let me show you more details about it. Just give me 1 minute. So how to access this batch, how to participate in the course that is given to all of you. So if you check the video's description, this video's description, you're going to find over here, register for Pariksha Veera. Click on that link and this web page will open for all of you. This web page will open for all of you. You can see Pariksha Veera KCET full year course 2027, okay, for 12th and KCET. If you go on buy now, you can find there's an onward offer going on right now, okay, till your Sunday midnight, only for Independence Day. This is the offer, okay. 2499 is the price from the original 4999 for the entire course. Okay, so enroll right away. There are a lot of features you can check over here. You have in-class doubt solving, in-class quizzes, leaderboards, discussion of the practice questions, regular assignments, 20 plus part and full length test analysis, again lectures also. You have a proper schedule you can check once you enroll. Okay, so this is your the batch started from 6th of July. So all the classes for the last 1 month that you have missed will be provided to you all in a recorded format, and all the upcoming classes will be live. So go talk to your parents, make an informed decision, take this batch as soon as possible. Okay, if you are looking for a structured preparation of KCET and your second PUC board. Okay, so yes, the offer is only valid till, as I mentioned, Sunday midnight. Okay, that is going to be 16th of August. Then if you want to be participating in this offer for this particular batch fee to enroll at 2499, again this is for the first few seats. It will not be possible to give for everyone, so try to take it as soon as possible. Try to take it as soon as possible, guys. Okay, so that's all in this class where I talked about integration by parts. And if you are serious, if you are looking to study with us in our Pariksha Veera batch, enroll right now. See you all in the next class. Till then, take care. Bye-bye. All the best.